Welcome to This Explainer. Today, we are jumping straight into a high-stakes, multi-million-dollar battle that is literally reshaping modern manufacturing as we know it. We're going to unpack the intense race to automate airplane assembly, and specifically, we're looking at how two aerospace absolute titans, Boeing and Airbus, have tackled this massive, massive challenge.
Okay, so you might be wondering, why can't we just build airplanes the exact same way we build cars? I mean, the auto industry has been using automated assembly lines forever, right? Well, that's because they deal in high volume and lower tolerances. Aerospace is just in a completely different league. We are talking about colossal structures, ridiculously strict tolerances, much smaller production runs, and of course, products that have to stay safely up in the sky for decades. It is a whole different ballgame.
To really wrap our heads around the kind of scale we're dealing with here, take this staggering number, 60,000. That is the exact number of individual rivets human mechanics historically had to insert by hand using handheld tools into just one single Boeing 777 fuselage.
Which brings us to the million-dollar question for today's explainer. How on earth do you take a process that requires sinking 60,000 fasteners into massive curved metal panels and hand that completely over to a machine? How do these giants deploy robotics for such grueling, physically demanding tasks without compromising even an ounce of precision?
Let's start with Section 1, Boeing's ambitious robotic experiment. So, Boeing's initial approach to this was an initiative called FOB. That stands for Fuselage Automated Upright Build. They built this with KUKA Systems, a company that actually has really deep roots in auto manufacturing. The idea was to have robots working in perfect tandem on both the inside and the outside of the aircraft. Their job was to drill holes and fasten these huge metal panels that were held upright, basically trying to completely replace the human mechanics who used to do this by hand. On paper, sounded absolutely flawless, a mechanized workforce that literally never gets tired. But the reality? Well, it was a massive production snarl. The robots really struggled to stay in sync with each other across those hulking metal panels. The inside robot and the outside robot would just fall out of alignment. And this led to incomplete jobs, massive bottlenecks on the factory floor, and a huge wave of worker overtime just trying to fix the mistakes after the jets rolled off the line.
And you know, the sheer toll this failure took on the team was intense. Jason Clark, who was the Boeing vice president overseeing 777X production at the time, perfectly summed it up. He literally said, "It was hard. It took years off my life." It just proved that, at least in this specific instance, the raw dexterity and visual precision of a human being simply could not be replicated by a machine.
Which brings us to Section 2, the pivot to flex tracks. Recognizing they had a serious bottleneck, Boeing didn't just blindly double down on a failing strategy. After about 4 years of trial and error, they actually scuttled those fully automated FAUB robots and pivoted. They shifted to a technology called FlexTrax, which was a system they had already been successfully honing on the 787 Dreamliner. As Boeing spokesman Paul Bergman noted, this alternative solution proved vastly more reliable than the fully autonomous bots. It required way less rework, which ended up being a huge win for the human workforce. What they found was a brilliant new division of labor. The super physically demanding, highly repetitive job of drilling thousands of holes through metal, that is now handled by automated FlexTrack machines built by Electroimpact. Meanwhile, the actual fastening and riveting, the stuff requiring that unmatched visual precision, was given right back to skilled human mechanics. They basically found the absolute perfect hybrid sweet spot between robotic muscle and human finesse, boosting both factory flow and worker safety. Moving on to Section 3, Airbus's Hamburg Assembly Triumph. Meanwhile, right across the Atlantic, Airbus was facing a very similar automation challenge, but they took a totally different and highly successful route with their popular A320 family over in Hamburg, Germany. To understand why it worked, we gotta look at their old way of doing things. Airbus traditionally assembled planes across 4 legacy stations. It was this very linear, highly manual, straight-line process using fixed gantries and deep pylons to move from riveting the fuselage all the way down to final cockpit installation. But then they built Hangar 245, and they completely shattered that traditional straight-line model. They built this revolutionary, highly automated prototype line that operates in a flexible spiral rather than a straight line. And by doing that, they were able to completely eliminate all those cumbersome, fixed gantries holding everything back. And the driving force inside this brand new hangar? 20. That is the number of highly advanced, specialized robots integrated directly into this assembly line. And these aren't just off-the-shelf machines either.
They are a customized fleet designed to push productivity up by an incredible 20 to 30%, all to support the massive A320 ramp-up.
Section 4. Meet Louise and Renate. So working inside this fleet are two famous 7-axis robots that the factory workers affectionately actually named Louise and Renate. These customized machines are beasts. In the initial assembly phase, Airbus uses 8 lightweight MTM Robotics flex tracks. They travel on a vacuum rail right along the curved fuselage, and they drill up to 2,400 holes per joint. Then, robots like Louise and Renate, which are part of a 12-robot KUKA fleet, step in to join the fuselage to the tail. They seamlessly drill, seal, and insert up to 3,000 rivets per orbital pass. It is just a staggering volume of work.
But here's the thing. Louise and Renate do not operate in a vacuum. Airbus surrounded them with this massive, highly connected automated ecosystem. We're talking laser measurements that can position giant fuselage shells with 0.2 millimeter accuracy. They've got autonomous guided vehicles zipping around for logistics. And they've expanded robot applications to cover everything from welding and sanding all the way to painting. Plus, the whole shebang is tied together by a digital twin system that collects constant sensor data to optimize every inch of the factory floor. Now you are probably thinking, wait, how did Airbus avoid that exact same synchronization snarl that doomed Boeing's FUB robots? Well, a huge part of their secret weapon is advanced software, specifically something like InSphere's ORA. This tech tracks robot movements and fixture alignments in real time. If it senses even a microscopic misalignment, the software instantly updates the robot's process without any human having to intervene. It corrects the exact variations that used to cause those massive factory bottlenecks. Pretty brilliant. Finally, let's look at Section 5, the future aerospace workforce. Because all of this incredible technology, from flex tracks to 7-axis robots to laser-guided inspection, it brings us to one critical question for this explainer today. What happens to the human worker on the factory floor? Airbus has made it super clear that their strategy is deeply human-centric. They're deploying automation strictly to take over the rote, repetitive strain tasks, like drilling thousands and thousands of holes. This protects the workers physically, and it frees up human operators to tackle complex, diversified, value-added tasks that really require human creativity and judgment. So, as we watch Boeing pull back to that sweet spot hybrid model and Airbus push the envelope with incredible spiral automation lines, it leaves us with this final thought. In the ultimate aerospace factory of the future, will humans disappear from the floor entirely? Or, as these advanced systems take over all the heavy lifting, will our jobs just naturally evolve into managing the machines? Thanks so much for joining me for this explainer, and I'll leave you to chew on that one.